Okay, so we're trying to find the equation of the normal to the tangent of this function at this particular point. Now, to answer this question, the first most obvious thing you need to know is, well, what is a normal? A normal is very similar to a tangent. It's related to the tangent, actually. So if you know what a tangent is, you can define the normal. So what's a tangent, again? Comes from, if you remember, it comes from the Latin word tangere, where we get the word tangible, which means just touching, right? So for instance, if you've got a graph that looks like this, then a tangent is going to just touch the curve at the point where it's touching. Okay, so for instance, something like this, I missed, yeah, the idea. That point there, right there, the tangent and the function itself, they share the same gradient, and of course they share that point as well. Okay. Now, what's the normal? What's its relationship to the tangent? It's going to be going through the same point, but instead of being equal to the gradient, it's going to be perpendicular. Okay, so you're going to get a 90-degree angle there. Okay, so how does that affect what we're going to do? Very simply, it'll be just like working out the tangent, but with one difference, namely that the gradient is not going to be the same. We're just going to take the negative reciprocal. Okay, so let's give a go at this question. There's a point supplied to you here. So there's my x value 3 and my y value 6. If they don't give you that, they'll give you some other kind of information to pin down exactly where they want the normal to be. Okay, so we want to work out the gradient at that point and then take the negative reciprocal. So as usual, we'll use the derivative to do that. So if this is y, then it's a pretty simple derivative. Okay, 2x minus 1. So I can say at the x coordinate, x equals 3, right? The gradient of the tangent is going to be, so sub 3 in, I'm going to get 6 minus 1, so that'd be 5. Okay, so there's the gradient of the tangent. So therefore the gradient of the normal is going to be the negative reciprocal, so say minus 1 over 5. Okay, now by the way, just as a small note, because you're going to be talking about all these different gradients in the gradient function, I think it's important to actually label what they are so you don't just have random numbers flying around. Okay, now that you know the gradient of the normal, now you just have to put it into the equation the form for the equation, which is point gradient form, right? So the equation of the normal will be given by this. We already know what x1 and y1 are, 6, 3, and that gradient of the normal is going to come in here. Now you could expand, I suppose, but it's kind of neat to have it in general form. Often that's the best way to present. So I'm going to multiply through by minus 5, which will give me minus 5y plus 30. This will just be x minus 3. And then I'll tidy up just by bringing everything onto one side. So it's going to become x plus 5y minus 33 equals 0. Okay. Now, there's the equation. I'm done with the question. But just to check, I mean, you know, they might have asked us to, a pretty ordinary thing to ask is to not just find the equation, but to graph it. Even if you don't get asked to graph it, it's kind of handy just to draw yourself a rough sketch so you know you're in the right ballpark. So what does this equation look like? If you factorize, that's x minus 1. So it's a parabola, and it's going to go through 0 and 1. Those are the intercepts. Okay. Now this point 3, 6, 1, 2, 3. I might put it, say, well, let's draw this like so. Okay, now if that's what the parabola looks like, so that's my point up there, 3, 6. Now, what did I already know about it? Well, the gradient of the normal is going to be minus a fifth. Now, does that sort of match up with what I'm going to have? Yeah, I think it does, because this is kind of skyrocketing, it's getting steeper and steeper and steeper. So therefore, this is kind of the equation of the normal that I'm after. So it's in the right ballpark, just to verify it, and that's actually the equation that I want. So just to review, how do you find the equation of the normal? In much the same way you find the equation of the tangent. So differentiate so that you can find the gradient at a specific point. Find the gradient at the point you're after, and then take the negative reciprocal, since you want that perpendicular, okay? And then proceed as you normally would, putting it into point gradient form and simplify out to get your equation.